Math class. It's not enough that we've already learned how to solve quadratics with factoring and the quadratic formula, two methods, but school makes us memorize yet another way. Probably a fair amount of you didn't even realize that you could use either method and were just doing what the sheet was telling you to do. Did you really just let a piece of paper tell you what to do? Anyways, here we are. You need to be in school and I want to grow a YouTube channel. So here is how to solve quadratics by completing the square. P.S. Be sure to watch this whole video because I show you tricks to make this method faster and easier once we get the hang of it. Let's assume that you have a quadratic equation that's ready to go. By that, I mean you don't have to do any shuffling or combining like terms until it's in standard form. In other words, the 0 is on one side and the 3 other terms are on the other. Completing the square is an algebraic trick that I perform on the first 2 terms of the equation, which pays off a few steps later by allowing me to solve the equation by taking the square root of both sides. Let's say that this is the equation that I wanted to solve. Completing the square is a trick that I do on the first 2 terms of this equation to turn it from this into this. Now, why would I want to do this? Well, notice we're actually just a few steps away from solving this. Et voila, there's our 2 solutions. First solution is x equals minus 1 plus 3, which is 2. And the other is x equals minus 1 minus 3, which is negative 4. So these solutions should be pretty intuitive. They're directly in x equals form, just like how when you used to solve linear equations, the end answers is x equals something. And they don't use parentheses to kind of hide the answer like when you do it with factoring. The art of this whole method is therefore in the first step. How did I know to turn it from this into this? Well, it wasn't my idea. Someone long ago must have thought of it. But the point is to make the equation from something without parentheses into something that's x plus something squared, yada yada, so that I can take the square root to solve it. Remember, the square root doesn't work term-wise, so it's only through this trick that we can solve quadratics by taking the square root. So yeah, just thinking in my head for a second, x plus what squared expands into this? Well, x plus 1 squared expands to this. So that almost does it, but now we have this plus 1 at the end that we didn't have before in these first 2 terms. So in order to complete the square, we have to add a minus 1 at the end in order to balance it out. Therefore, to complete the square on the original equation, we turn it from this into this. Once we've done that, then we solve the way I originally showed. Another example to help you get the hang of it. Let's say that I wanted to solve this. Okay, well, in order to complete the square, again, I have to look at the first 2 terms. So how can I turn this into x plus something squared form? Well, just intuitively, there's only a few options. So let's say I tried this. Does this work? Well, if I expand this, I actually see that these first two parts do not match. So I want to try the next highest number, x plus 3. And hey, what do you know? It does match. Although, as I said before, we now have this plus 9 that came along and wasn't there originally. So in order to complete the square, we have to add a minus 9 at the end to remove it. Therefore, this original equation is equivalent to this. And now I can just solve. Combine these two. Bring this over to the other side. Take the square root of both sides. Don't forget that positive negative. And finally, move this last part over. Now again, this is a plus minus, so that means there's two solutions. One of them when the equation uses the plus, and the other when the equation uses the minus. So the first one is x equals negative 3 plus 1, which is of course negative 2. And the other with the minus, so x equals negative 3 minus 1, which is negative 4. So here's a nice fact. The number that we pick to be in the parentheses is always actually exactly half the middle number in the original equation. So notice the original equation had the number 6, and therefore the number in our parentheses will be positive 3. This is true even if the middle number is not an even number. For example, let's say I want to solve x squared plus 3x plus 2. Then following this rule that the term inside the parentheses is just half the middle term, I know that all I have to do is this. And the unknown part we can find by just doing the expansion and that last term, it's just that subtracted. Now I'll solve to finish this off. And there are my two solutions. Nothing a grade school fractions veteran shouldn't be able to handle. Now, what do I do if the leading term in my equation is not equal to 1? So for example, let's say this was my equation. So this scenario is actually really easy, and it's kind of the scenario when your teacher is just trying to trick you. So here, everything is divisible by 2. So all I have to do is divide by 2, and this pretty much becomes the same equations as we had before. And then we solve the way I showed you before. The other more complicated scenario that you will encounter is when things don't divide so easily. So for example, let's say I want to solve this. Now there's a few curveballs here. First of all, the terms aren't in standard form, so let me just quickly first fix that. And now we're at the part where we have to solve this, but the leading term is not equal to 1. Well, the solution is actually fairly simple. We just divide the whole equation by the term that is in the front. So in this case, 3. We divide this whole thing by 3. And that gives us x squared plus 8 over 3x plus 4 over 3 equals 0. Now, obviously, this is not a very pretty equation, but given the previous example and the fact that we all should know how to handle fractions, this is in principle solvable the same way I taught you before. So after simplifying and careful fractions algebra, we get our final answer. So it's important to note that you're not always going to be able to simplify the square root when you try to take it. So for example, let's say I tried to solve this equation. So notice at this step, there is no square root of 5. So all we can do is leave it as is, leave it as a radical. And there is our two solutions. Now here's an example equation that will give us complex solutions. So don't get tripped up by the fact that this equation is not using x and it's using k. That doesn't really matter. We just solve it the same exact way. And here's where the complex solution comes in, because when we take the square root, we get the square root of -1, which is of course I. And there's our two solutions. Now that one was a little too easy, so here's a harder complex quadratic example. First of all, this isn't in standard form, so I'm going to fix that first. And also, the leading term is not 1, so I have to divide this whole thing by 9. Not looking pretty so far. And there's our solution, and yes, I almost forgot the positive negative. One final note, going back to our second example, after completing the square, the way we have been figuring out what the question mark should be has been to work out the expansion on the side and then subtract away the third term. Notice though that this will always just be the square of the term that we picked to be in our parentheses. This term could also, if we want, be represented as a formula. Since this number is half of the b term in a standard form quadratic, and then you square it. Some teachers prefer to show it this way. And yeah, that's completing the square. So what's great about this method is that, as you can see, it solves any quadratic, not just ones that have pretty coefficients. And actually, while you may have been led to believe that the quadratic formula is something entirely different, They're actually identical. The quadratic formula is completing the square, just in the case where you don't have numbers as your coefficients, but letters. You can look up proofs online showing that this is the case. I'll leave a link in the description. So I won't do any word problems or application problems in this video. Just remember that, like the quadratic formula, this method solves all quadratics and is a great choice for many problems. Thank you for watching.